Hello students, welcome back to chemistry class. Today we are going to discuss about the preparations of amides, in which the first method is reduction of nitro compounds. Nitro compounds means NO2 group attached to the alkyl or aryl group, that is RNO2 or ARNO2, that is alkyl group or aryl groups attached to the NO2 group are to be called as nitro compounds. So these nitro compounds to be converted into amines by using reducing agents, such as lithium, aluminum hydride, and also hydrogen in the presence of nickel or palladium or platinum catalyst is also to be used, or Sn in the presence of HCl, that is tin in the presence of hydrochloric acid, or iron in the presence of HCl. So these are the reducing agents are generally used to convert these nitro compounds into amides. So let us take RNO2, that is alkyl group attached to the nitro group. So this nitro compounds undergoes reduction in the presence of Sn or tin and concentrated hydrochloric acid. So this nitro group, that is oxygen atoms, are replaced by the hydrogens. So that process are generally to be called as reduction process. Reduction is nothing but addition of hydrogen and removal of oxygen. So it gives the product, that is RNH2, and the released oxygen atoms combines with the hydrogens and it forms H2O molecules. That is, it requires 6 hydrogens and it eliminates 2 moles of water molecules. For example, let us take methyl nitrate, CH3NO2, that is methyl nitrate. So this methyl nitrate undergoes reduction in the presence of Fe plus HCl. So it gives the product, that is CH3NH2. So it is to be called as methyl amine plus the byproduct is H2O. So it requires 6 moles of hydrogen and it eliminates 2 moles of water molecules. That is, when methyl nitrate and reduction in the presence of reducing agents such as FeHCl or SnHCl, so it gives methyl amine. For example, let us take aromatic nitro compounds, that is NO2. So this compound is to be called as nitrobenzene. So when nitrobenzene on reduction in the presence of Fe plus HCl, so the hydrogen atoms replaces oxygens in the nitrobenzene, so it gives NH2, that is to be called as aniline, plus 2 moles of H2, that is it requires 6 moles of hydrogens. So this process is generally to be called as reduction of nitro compounds. Here the reduction with iron and hydrochloric acid is the preferred method, because during the reaction FeCl2 formed gets hydrolyzed to release the hydrochloric acid, that is Fe plus HCl, it produces FeCl2. and it gets hydrolyzed to release hydrochloric acid. Hence, only small amount of hydrochloric acid is required to initiate the reaction. That is, in order to initiate the reaction, it requires very small amount of HCl. And next method, that is ammonolysis of alkyl halides. Ammonolysis. What is this ammonolysis? So ammonolysis means the cleavage of RX bond or CX bond by the presence of ammonia. That is RX, that is alkyl halides, reacts with the ammonia, that is NH2. So X and hydrogen is to be eliminated, and the reaction takes place in the presence of alcohol. So such process are to be called as ammonolysis. That is the remaining product R and NH2. So it is to be called as amides plus HX. So this process is generally to be called as ammonolysis. Ammonolysis means the process of cleavage of CX bond, that is in the alkyl group it contains carbon, that is the carbon halogen bond is to be cleavage by the presence of ammonia or with the help of ammonia. Such process are to be called as ammonolysis. For example, let us take CH3, CH2 and Br. So it is to be called as ethyl bromide. Ethyl bromide. So this ethyl bromide reacts with the ammonia in the presence of ethanol. In the presence of ethanol. So hydrogen eliminated along with the halogen. So the remaining product is CH3, CH2 and it is NH2 plus HBr. So the obtained product is to be called as ethyl amine, or it is to be called as ethanamine, right? Ethanamine. So when benzyl chloride is heated, that is C6H5 and it is Cl, so it reacts with the or heated with the ammonia NH2, and the reaction takes place in the presence of any alcohol. So there is an elimination of H and Cl. So it gives the product, that is NH2 plus HCl. So this compound is to be called as aniline. So it is chlorobenzene. So when chlorobenzene reacts with the ammonia in the presence of an alcohol, it produces aniline. And the obtained primary amines, that is one alkyl group attached to the nitrogen. So this primary amines, again it reacts with the 1 mole molecule of Rx. So one hydrogen in the primary amine eliminated along with the halogen, so it gives minus HX. So the obtained compound is to be called as secondary amine, right? So this secondary amine again reacts with the Rx. There is an elimination of one more HX, so it gives R3N. So it is to be called as tertiary amine, that is 3 alkyl groups attached to the nitrogen. Again this tertiary amine reacts with the 1 mole molecule of Rx. So here there is no any hydrogen atoms in the tertiary amines, and this tertiary amine reacts with the 1 more molecule of Rx because of the presence of lone pair of electrons on the nitrogen. So it gives R4N plus, and the halogen atoms gets negative charge. So it is to be called as quaternary ammonium salts. Quaternary ammonium salt. It is primary amines reacts with the alkyl halides, it gives secondary amines. Secondary amines again reacts with the alkyl halides, it gives tertiary amines. Tertiary amines on reaction with the alkyl halides, it gives quaternary ammonium salts. That is, by the limited amount of alkyl halides, it is to be converted into secondary. With the 2 moles of Rx, primary amines to be converted into tertiary. With the 3 moles or excess of alkyl halides, the primary amines to be converted into quaternary ammonium salt. That is, the type of product or type of amine is to be formed depends upon the number of moles of alkyl halides. But there is one disadvantage in the ammonolysis, that is, ammonolysis gives a mixture of primary, secondary and tertiary amines, right? During the ammonolysis reactions, it gives the mixture of primary, secondary and tertiary amines, and also a quaternary ammonium salt. So this quaternary ammonium salt is formed by the excess of alkyl halides. However, the primary amine is obtained as a major product by taking the large excess of ammonia. By the presence of large excess of ammonia, we can prepare the primary amine as a major product. And the order of reactivity of halides with the amines is Ri, that is, alkyl iodides are more reactive with the ammonia than RBr and then RCl. That is, the order of reactivity of Rx towards ammonia. This reaction generally to be called as ammonolysis. And let us see the reduction of nitriles. Nitrile is nothing but the CN group attached to the alkyl groups. Such compounds are generally to be called as nitriles. Or these compounds are also to be called as cyanohydrocarbons. And this reaction is to be called as Mendeus reaction. Let us see how to convert these nitriles into amines. That is, when nitriles, that is RC triple bond N, that is between the carbon and nitrogen, it contains triple bonds. So these nitriles on reduction with the hydrogen gas in the presence of nickel catalyst, and the temperature is 140 degrees Celsius and 130 atmospheric pressure. So this double bonds replaced by the hydrogens, right? So C, and it is single bond, and 2 double bonds, and it is nitrogen. So this bond, that electron is combines with one hydrogen, and it is combined with one hydrogen, and it is with the one hydrogen, and it is with the one hydrogen. So finally it gives the product, that is RCH2, right, single bond, and the two hydrogens attached to the nitrogen. So it is to be called as amines. It is to be called as amine. For example, let us take methyl cyanide, CH3Cl. It is also to be called as, that is methyl cyanide or ethane nitrile. Ethane nitrile. So ethane nitrile is IUPAC name. Eth means it contains two carbon atoms, that is eth, and between the carbon atoms it contains single bonds AN, and nitrogen is to be represented as nitrile. So this ethane nitrile reacts with hydrogen in the presence of catalyst, that is nickel, and it requires 2 moles, and the temperature is 140 degrees Celsius and 130 atmospheric pressure. That is, the reaction takes place at very high pressure. So the double bonds are replaced by the hydrogens, so it gives the product CH3 CH2 NH2. So the obtained compound is to be called as ethyl amine or ethanamine. So this is to be called as Mendes reaction, that is conversion of nitriles into amines. Here also different reducing agents to be used in order to convert nitriles to amines. That reducing agents are, that is lithium aluminum hydride and sodium amalgam in the presence of ethanol, that is C2H5OH. So these two reducing agents also used in order to convert these nitriles to amines. So Mendes reaction is nothing but the reaction takes place in the presence of this nickel and hydrogen. So that reaction generally to be called as Mendes reaction. Next, reduction of amides. Amide is nothing but, that is RCO group attached to the nitrogen. RCO group attached to the nitrogen, such compounds are generally to be called as amides. So in the amines, R group directly attached to the nitrogen, so it is amine. But here RCO group attached to the nitrogen, hence it is to be called as amides. So this amides to be converted into amines. So how to convert these amides into amines? Again we are going to do the reduction reaction, that is the replacement of oxygen with the hydrogens. Let us see how to convert these amides into amines. So amides on reduction in the presence of reducing agents, that is lithium aluminum hydride, followed by the hydrolysis. So it gives R, that is oxygen replaced by hydrogens. So one oxygen atom is replaced by the two hydrogen atoms, because between the carbon and oxygen it contains two bonds, and the remaining is NH2 plus the byproduct is water molecules, that is H2. So the obtained product is to be called as amines. For example, let us take CH3, C double bond O, NH2. So this compound is to be called as acetamide. Acetamide. CH3CO is acetyl group and it is amide. So acetamide, on reduction in the presence of lithium aluminum hydride and followed by hydrolysis, so it gives the product, that is CH3, and CO group to be converted into CH2 group and then NH2. So this compound is to be called as ethanamine. Ethanamine plus the byproduct is H2. So in order to convert these amides into amines, the strong reducing agent, that is lithium aluminum hydride, is used.